Hi guys! I just wanted to go over the last question on your lab number 3 because there were quite a few people that still had some confusions as to how to do a problem like this, and this kind of problem is going to be very important for your midterm exam, which is this week. So anyway, I want to go over, this is the last question on lab number 3, which had to do with the flasks and the balloons inflating. So I'm going to write out the equation that's governing this particular reaction. It is magnesium solid plus 2 hydrochloric acids goes to make hydrogen gas and magnesium chloride. Now this is the balanced reaction that we're going to use later in this problem. So it asked you had these two flasks, flask A and flask B, and it asked you which one was going to have the biggest balloon on top. Now the biggest balloon is going to have the most hydrogen gas in it. So we're going to go through and figure out exactly how much hydrogen gas is going to be produced in each flask. So the first one we're going to start off with is flask A. And the important thing to remember in both this problem and in a lot of other problems that you're going to find on your midterm is to always assume that there's going to be a limiting reactant, even if the question doesn't tell you. Just always assume there's going to be a limiting reactant. So we're going to go through in each of these flasks and figure out which is the limiting reactant, as well as how much hydrogen gas is going to be produced. So flask A. Flask A, we were told we had 5.10 grams of magnesium. The first thing to do if you're ever stuck on a problem like this is to solve for the number of moles you can, because you have your periodic tables, you can figure out the number of moles that you have. The way I'm going to be doing these problems as well too is with a particular grid to work through the equations. Obviously when you enter everything into Sakai, you don't have to do it like this. You can just show me your fractions that you use for all the conversions. Most of you have been doing a great job with that so far. So we have 5.10 grams of magnesium. We're going to convert to the number of moles of magnesium. So we have 1 mole of magnesium, and the molar mass of that is 24.31 grams in magnesium. Okay, so after we do this particular equation, or this particular calculation, we're going to have the number of moles of magnesium. Now the number of moles of magnesium isn't exactly what we're looking for. We want to figure out how much hydrogen there is in this equation. And the way you can do that is you can use this chemical equation to figure out what the ratio is between the magnesium and the hydrogen. So if you can look in the front of this equation here, there's a 1 right here, so there's 1 magnesium for every 1 mole of hydrogen gas. 1 mole of magnesium for 1 mole of hydrogen. So we're going to go ahead and put that in our equation. So we have 1 mole of hydrogen for every 1 mole of magnesium. Now I have the moles of magnesium on the bottom because our units are going to cancel out. I'll go through and I'll cancel out some units here. We have grams of magnesium here that we're going to be able to cancel out when we do this in our calculators. Grams of magnesium. We're going to have moles of magnesium that are going to cancel out. We're going to be left so far here with moles of hydrogen gas. Now the moles of hydrogen are, let's see here. The moles of hydrogen is what we need to solve. We don't need to solve for the mass of hydrogen or anything. We just need the final moles of hydrogen. So if we work this all the way out, we're left with 0.21 moles of hydrogen gas. Okay, so 0.21 moles of hydrogen gas. And we're going to write this down so we can remember it. My whiteboard is not big enough for us to do all the work of this problem all on the same whiteboard. So now we're still in flask A. We were given this much magnesium. Let's go ahead and figure out how much it is with the hydrochloric acid to see which one of these is limiting. So for the hydrochloric acid, we were given 0.477 moles of hydrochloric acid. Again, we can use this equation up here to convert between moles of hydrochloric acid and moles of hydrogen gas. They're in a 2-to-1 ratio. Remember, in an equation like this, if there's no coefficient, it means 1. Okay, so I have 0.477 moles of hydrochloric acid, and we're going to go ahead and convert that. We have 1 mole of hydrogen gas for every 2 moles of hydrochloric acid. So what you can see here is that the moles of hydrochloric acid are going to cancel on the top and the bottom, because remember, you multiply if it's on the top, you divide if it's on the bottom. So we're going to cross out this moles of hydrochloric acid, and we're left with moles of hydrogen gas on the top. And if you work this out, it's 0.24 moles of hydrogen gas. Now, we went through and we figured out how much hydrogen gas we were going to get if magnesium was the limiting reactant, and we figured out how many moles of hydrogen gas if hydrochloric acid was the limiting reactant. So now we can look at these two answers and we say which one is the smallest. The magnesium one is the smallest. So magnesium is the limiting reactant in this equation. Okay, so we're going to have up here, I'm just going to kind of write our answer for flask A. Actually, let me see, let me erase this. Flask A was 0.21 moles of hydrogen. So we're just going to kind of set this to the side because we're going to go through and solve for flask B right now. Okay, so magnesium was the limiting reactant in this equation. So I'm going to erase this here, and we're going to work through the exact same steps for flask B.